For part one of the lab, we have a variable gap capacitor, and I will zoom out at the end of this lab and show you that, and I will also put in the measurements. But right now you are currently able to see the gap distance and the current measurement for capacitance. You'll be using this to create graphs of relationship between capacitance and D. So in the settings right now, this is in the 2 nanofarad setting. 2 nanofarad means that is the most that setting can handle. It is not a multiplier. The only thing that matters about that is the units, nanofarads. So currently, with the gap that you see, it is 0.32 nanofarads. I'm going to adjust this variable gap capacitor at intervals in which you will need to stop the video and take the measurements of both distance and capacitance. I'm going to stop here for a second and show you. This now says 0.001 nanofarads. I can now move down to the lower scale to the 200 picofarad scale because this is less than 200 picofarads. So the measurement for that is 23.4 or 23.4 picofarads. So let's keep moving along. And that'll be the last measurement. You can use any or all of those measurements. I did not take them in any particular increment of spacing. You need to decide for yourself on that. These units are in centimeters. For part 2 of the lab, we have 2 demounted capacitors. In between, there are 5 small spacers which we can neglect in terms of their dielectric constant. For that, it'll be the dielectric constant of air. To determine the dielectric constant of that material, we'll take a measurement before, seen on your screen, 0.096 nanofarads. I will remove those 5 spacers, replace it and retake that measurement. That measurement is now 0.304 nanofarads. By taking the ratio of those two values, you'll be able to determine the dielectric constant. Now I will go back to using my 5 spacers. I'll replace the 2. Except now, I'm going to take the measurement of the capacitance in series and in parallel. So before we do that, let's get the capacitance of this second demounted capacitor. The capacitance of the second one is 0.099 nanofarads. Okay. To measure the capacitance in series, what we need to do is create one single loop. So I'm going to remove the top here. I'm going to add a connector from the top, and I will choose to put it on the top of the second. And back. So if I follow it with my finger, let's trace these paths. I follow this down and back. So that is one series loop, which gives me a total capacitance of 0.038 nanofarads. Now let's unhook these and hook these up in parallel. To do that, I will use a red one to go from top to top. I'll use the black one to go from bottom to bottom over here. So now we need to add our measurements. I will add one to the bottom. I will add the red to the top, and I get a total capacitance of 0.22 or 4 or 225 nanofarads. Let's trace the path of this one. I have the red over here going in, and you can see that the capacitor goes down, but this red wire goes to the second capacitor. So we have a split in the path right here. This split tells you you have a parallel connection.